So now securing applications through the lens of, through the attacker's lens. Here's Roy Talyosef. He's a founding engineer at Codium, a company specializing in application security solutions. Prior to joining Codium, he was a part of the vulnerability research team at NSO Group, where he contributed to the development of the Pegasus spyware with extensive experience in identifying and exploiting software vulnerabilities. Talyosef focuses on enhancing security measures in cloud-native and distributed systems. So please welcome Roy.
Thank you. I feel like this might make me serious. So thank you, everyone. Very excited to be here with you. We're going to speak mostly about the experience we had in NSO Group and how we translated those into security. So a bit about myself and my background. So I currently work for Codium. It's a cybersecurity company. We focus on code to runtime security. But before that, I was in NSO Group, part of the iOS team, really focusing on iOS devices, how to crack them, and how to get as many information from them. So maybe before we jump in, why do we think it's important in, you have to mention at least once in a cyber conference, right? So it's mainly to know your enemy, what you can learn from the enemy, what you can learn from the ways, and really get to know, can put you one step ahead. Okay, so it's one step ahead of your enemy. It can be a matter of life or death in cybersecurity, right? So for those here, is there anyone not familiar with Pegasus or NSO Group? That's super okay. So for the shy one, perfect, yeah. So NSO Group is a cyber offensive company based in Israel. It's the company behind Pegasus. Pegasus is an offensive tool to crack phones, and it's basically a spyware, okay? It's meant to gather as much information about the client and agent and get it all back to the, our customer. So even though it's a spyware and it cracks phones, we actually had to compete with top security teams. So whether it's Apple, Meta, Google, so I think those lessons are really valuable to all of you, in your day-to-day and how you go into securing your own product, your own software, your own servers. So, so when competing with top security teams, I think you can relate, most of the time security teams are small teams, also offensive teams are small teams, and you just getting overwhelmed. So those can take advantage of to compete with those kind of companies. So let's start with talking about vulnerabilities and SLAs. So this is distribution, the general distribution of vulnerabilities. As you can see, the number might not mean too much. There's tons of vulnerability out there. I think I read a stat earlier this week. It's 60 new vulnerabilities disclosed each and every day, and those are only the ones disclosed. Now with AI, we have more code, we have more vulnerability, and it's getting over and over again. But the interesting thing to see here is the distribution. Okay, so those are the normal severities, right? And medium and low vulnerabilities, they're about between 60 and 70% of all the vulnerabilities. Okay, and when we as an attackers want to leverage a vulnerability, we want a few things from it. So first, we want it to work, right? We want it to be able to exploit the system. But then we also want it to be used as much as we can, okay? Because like every other engineer, we're lazy. We want, when we do something, we want it to work for as long as possible. And that's when SLAs plays a crucial role. So critical and high vulnerabilities usually get a lot of attention and focus from security teams. So critical, you know, some teams it's a week, 2 weeks, some even 48 hours for some severities. High, probably the same. But when we talk about medium and lows, there are organizations that won't bother with them so much because they're overwhelmed with the critical and highs. So those vulnerabilities are gonna stay there much longer than higher severities. And that's only because how security team focus. And the second thing that is interesting that we do it, sometimes it's the same code, sometimes it's the same developers, but we were also able to extend the number of vulnerabilities, specifically also medium and low, for more undisclosed vulnerabilities. So for us, it's also important because eventually those will be patched, right? The maintainers will patch it, they will have new version out, and then again, when the new undisclosed vulnerability will be disclosed, we will have more time. Okay, more time means that we can get faster to market, and faster to market for an attacker is exploit as soon as possible. So the second thing is about security, security tools and what we use. So security tools are usually noisy. They're noisy because they track all those vulnerabilities. There's thousands of them, and they want to make sure you get everything. Okay, so it's common to see like thousands of vulnerability in a system, and I think like when you connect a new tool, you get instant alert fatigue for that reason. And we conducted a survey, and we found that 78% of AppSec team uses more than 5 tools. This creates a bit of a spaghetti, right? Because you have a lot of tools, each one has different criticality, different scoring system, and each one wants you to focus on what is telling you, right? So it can be a bit hard to prioritize in this way. And the last thing is every tool has its own context. So there's the best AppSec tool, the best CSPM, the best you name it, and it focuses on a very specific kind of vulnerability or specific kind of components in your system. Okay, so again, it gives you the score for this specific type of component, but usually it's not just a single component, right? Systems are complex. We need to exploit them. We need a lot of different steps and different vulnerabilities, and that also plays a huge role when trying to identify those different vulnerabilities. So it's a good place to just, if you have any question around vulnerabilities or anything like that, super clear. Perfect. So what can we actually do? Okay, what can we do in order to stay safe or stay one step ahead of those hacker teams? So I want to introduce you to the MITRE ATT&CK. It's a great framework. Is anyone familiar with the MITRE ATT&CK? Awesome. Great, about half the people, so it's super great. So the MITRE ATT&CK, it's a framework to help us create a common language and common understanding around those kind of vulnerabilities, hacking and stuff. Really, you can see here a few examples or all examples of the tactics that hackers do in order to gain some sort of advantage or gain some sort of exploit in your system. Okay, so it can be data exfiltration, persistence, defense evasion, all those things, and all these different tactics are something that we as hackers, we actually try to do, okay? And now when we have all those vulnerabilities and all those findings, we can start thinking of them as tactics, okay? Because the vulnerability itself, we want to use it for something. So what we try to do is to take those vulnerabilities and chain them together. And you can see here an example of what a chain is and why can be so helpful. So you can see it's like 5 different steps in this chain, different tactics. You can see that it has different vulnerabilities in it with different severities. So for example, all these beginning of the chain are critical, but you can see that we also use a medium vulnerability in order to exploit the system. And you can create the full story. Okay, so you can understand what this vulnerability role in the exploit. And using this story can also help you understand what the attacker might do, but it can also help you to explain to your own developers and really give them the right motivation and the right context in order to want to actually resolve the issue fast. So another interesting thing we can see here in this chain is not all the issues are fixable. Okay, only some of them, the first two are fixable, but the other two are not. So we can also prioritize a bit differently when thinking about it in chains. If we want to effectively break the chain, we can fix any of the fixable issues and provide us some sort of mitigation or some sort of protection against this chain and against this vulnerability. So, any questions? Fantastic. Okay, so when we start thinking about those chains, so we can see that the true scoring of an issue can change based on the context. So two mediums can be chained together and create an actual critical vulnerability, and the other way around. Like we can have 5 critical issues, but they're not part of any chain, so we can maybe postpone it for later, and really prioritize a bit differently. And also it's very effective. Chains are usually 3 or more vulnerabilities, so it's very effective to go chain by chain instead of just taking all the vulnerability as a huge pile of blobs that we just eat through them. Perfect. So the other part of the sentence, which is, I think, less known, is know yourself. So this is one of the biggest advantage that you have on top of the attackers. This is your system, you know it, and you can learn it in depth from obviously the people who developed it, the organization itself, and all the tools you can use. So the first thing you can do is really start to make an inventory list, go through all the different system. It can be container, VMs, really whatever you use, but really understand what you have, what you use, how you use it, and it should contain third parties. Then we can, on top of it, put like the mitigations that we have. We can have different tools, we can have different firewalls, we can have all sorts of different mechanisms to help us protect the system against those kind of vulnerabilities, and those mitigation can be crucial. I can tell you, like, usually mitigation are harder as an attacker, they're super effective, and having mitigation in place really boosts your posture scores tremendously. So the second thing that we can know now, the mitigation, we can understand what kind of vulnerabilities we can save for later. For example, is the vulnerabilities on require networks, public network, all those kind of things. And the last thing is start thinking on the chain. So it's not the specific example of the chain, but taking this into the MITRE framework and just trying to play with it, understand what an attacker would do, how will he approach the system in order to exploit it. So just want to mention a few open source tools that you can use to start, exploring. So there's SteamPipe, which is an awesome ETL, CSPM. You can query your cloud provider and get all the information about what you use in your environment. You also have SIFT, which is a great tool for SCA and SBOM and getting vulnerabilities information. And OpenGrep, which is the open source SemGrep fork that you can use to do some static analysis and really shed light on your source control and system. And obviously, you can take it all and just send it to your favorite AI provider to, play around and get extend stuff. And to make it short, I think the main takeaways are that hackers take whatever you give them. So they don't wait. They just take the first thing that's available on your system, and they're going iterative process. Okay, we have tons of constraint when we work as hackers, and it makes hackers usually creative. So we also think about the system in an holistic approach. So we don't see it as a, web server, other server which is not exposed to the web. We see your system. We want to exploit the system. We want to gain a specific advantage or to gain or to make a specific advancement in your system. So we take it as an holistic approach, and you should too. You should look at your entire system as a whole instead of one component at a time. And the third thing is chains. Okay, chains are important. As I mentioned, usually you have at least 3 vulnerabilities in a chain. So having only a single one can be a bit misleading, and the criticality and CVSS score is not tailored to your environment, so it can also be very helpful to chain vulnerabilities together in order to gain specific knowledge and understanding about your system. So, yeah, I'll be happy to take any questions. Yeah. Yeah. So just to repeat the question about examples for how critical vulnerabilities or medium vulnerabilities play different roles in a chain, right?
No, I wanted to know, because I don't know how to ask this question in the sense of, because like a lot of times when I see a critical vulnerability, it's like remote code execution.
Mm-hmm.
So obviously you want to patch that one, but you were suggesting that sometimes a chain of medium vulnerabilities could be somehow more critical than some critical vulnerabilities. Do you have an example of a critical vulnerability that would be important in a chain?
Yes, so I don't have a specific example for a vulnerability. So obviously sometimes you have the most critical vulnerability like log4j that you can, it's only one vulnerability that you can use, but most of the times, even for remote execution and stuff, you still have to get to this specific vulnerability. So you have to build a few steps in the way in order to get to this specific vulnerability that is more critical.
So it might not be necessarily a chain of all medium and all small vulnerabilities. It might be a chain of 2 medium vulnerabilities and a critical vulnerability.
Exactly.
Medium is get you to the critical.
Exactly.
And so you want to break that chain because then the critical doesn't matter as much.
Exactly. Yeah.
Makes sense. Thank you.
Perfect.
You mentioned a bunch of open source tools. There were 2 that I worked with. I'm not sure you mentioned them when I worked with that team, NIST and OpenCCI. Have you worked with any of these? What's your opinion? Do you recommend them? Or
What's the first one?
NIST.
MISP.
It's just a security intelligence collection tool, and I think it's been surpassed by OpenCCI.
Mm-hmm.
It gets more press. Have you worked with any of these, or is there one you recommend in this space?
Mm-hmm. So personally, I hadn't worked with those 2 you mentioned. I think there's tons of open source, good open source, and we also have a few standards like Cyclone DX or SPDX for SBOMs and vulnerabilities, which really help. And it's, you should use whatever is best for your stack. So your languages, your package manager that you use. That's the. Okay. Yeah, please. Yeah. So. Yeah. So about chaining, why not more companies use chaining or can help us build the chains? So, in my opinion, it stems from 2 different reasons. First one, tools wanna be super focused on a specific niche. So it's narrowing the context, and then what you can build, it's more challenging. For example, if you have endpoint security tools, it will only look on the API endpoints you have, but not on the SMO of the application or are the server used. So it's harder to build a full elaborate chain when you're very focused on a specific use case. And second, I think it's a bit challenging. I think with AI now, you're able to do more with building the context around the vulnerabilities, really understanding from the, the description of the vulnerability, what it can be used for, and now with the use of LLM, it's becoming easier to do it on a big scale. So I think that's the two main reasons. Yeah.
Question about libraries, specifically vulnerable libraries that are not called by the code that you've written. Have you seen examples where those are exploitable still, even though they're not called by a specific application?
So that's a great example for what we call runtime security. And it obviously depends on the ecosystem. If you're a part of the Python or Node.js, yeah, exactly. So you get tons of dependencies that you don't really use in your runtime, and being able to filter out the noise, but what you use and what you don't use, it's super effective. It's around 90% drop, I'd say, yeah.
And then if you optimize that with ProGuard, say that's no longer an issue, is that right?
It's less of an issue, yeah. It's almost a non-issue. It obviously depends on your compliance and policies in the organization, but yeah, like postures-wise talking, it's a non-issue, basically, yeah. Yeah.
How do you as a hacker start to identify the chain of vulnerabilities? Is it like, if I get in this way, then I know to also check here, here, and here type of thing? Or is it like, when you start clicking around and seeing what else you can do, or what's the strategy?
So we start by defining what we want to do with the system. So in case of Pegasus, it's a spyware. In the end, we want to get as much information we can from the device. So we try to build it usually from the goal backward. So then we look at the system and start basically asking all the questions you can around public APIs. We try to get the source code. Sometimes it's open source and it's available, and we try to look what vulnerability you have, do actual code review to the code, understand the system, the different components, the different type of things, and then, yeah, just going from there. Sure. So, anyone else? Cool, great. So thank you very much. If you want to see the survey results, you can scan the QR. It's pretty interesting to see how different security teams, tackle those issues. And yeah, we'd really like to talk with you afterward. We have a booth over there, and if you want to talk about, attacking, defending, and everything, and have any feedback around this short talk, be happy to talk with you. Thank you very much.